Hey guys, what's up, people? First of all, welcome to the session. I am so sorry for what happened before. I had no clue that there'll be no power. There was power till I don't know 5 minutes before the session, and after that the power went off, and I couldn't do anything about it. My internet stopped working. Everything just was a big, huge mess. But anyways, welcome back, guys. Welcome back. How are you guys doing? Thanks a lot for joining with me today. How are you guys doing? How many of you guys are excited for your science examinations? Yes, all good. Welcome, guys. Welcome. Hi, Amiraj. What's up, buddy? How you doing? How are you guys doing, people? Welcome. I am at home. I'm at home, Nivarika. I'm so sorry, guys. I'm so sorry for that. I really had no clue that that would happen. I was so excited. You have no idea. I woke up at 6 in the morning. I was like, okay, I'm like super joshed up for the session, but unfortunately, all of that happened. Anyways, welcome, guys. Welcome. Don't worry, whatever fear you have of physics exam today, we're gonna get rid of it. Not today. In the next 1.5 hour, we're gonna get rid of it. And also, we'll have one special guest joining us in the middle of the session. You can take a guess who's going to be that. I mean, who that person is going to be. But that is later on. But yes, first thing what we're going to do is today, guys, we are going to solve about 25 questions that I have in store for you guys. About 25 questions, both from Light and Human Eye and Colorful World chapter. And these questions have been repeated several times in your board exams, right? In past year board exams and all that. So we're going to do those questions first, and then we will basically try to clear some doubts as well. But yes, guys, because of what happened in the start, there's a small time crunch. From 2-hour session, it has now been reduced down to 1.5 hour. So we'll try to solve these questions as fast as possible, and more importantly, we'll try to clear your doubts as well during this 1.5 hour duration. Alright, guys, so excited. Unfortunately, guys, my Hindi is hopelessly bad. My Hindi is as good as Ja Simran Ja Ji Le Apni Zindagi, but I will try to go slow. I'll speak really slow, but unfortunately I can't speak Hindi. I am very sorry for that. Anyways, so guys, once again, very warm welcome. First of all, I would say this, guys, that I would like to say this one statement, that is this: you're braver than you believe, stronger than you seem, and smarter than you think. Every one of you guys are. You just need to find that inner strength, that inner courage, that willpower to get through these examinations. Now, first of all, I'm pretty sure that 99% of you guys have less anxiety compared to how it was yesterday or day for yesterday before your first examination, that is your social science, right? I'm pretty sure that a lot of you guys are feeling a little bit more calmer right now because you guys have that confidence now, because the first exam, I'm pretty sure you guys did well, right? How many of you guys are feeling confident about your first term examination, that is your social science examination? How many of you guys are more confident about it right now? Hi Sachil, what's up? Welcome. Yes, Niharika ji. I'll keep speaking Hindi until I make you guys forget Hindi. Yeah. Awesome, guys. That is really amazing. So you have to remember that your science exam is also going to be very much similar to it. They're not going to make it so difficult that you're going to do hopelessly bad in it. So don't worry. It will be easy. I mean, not that I've made the question paper, it's not that I've seen the question paper, but I'm pretty sure, I'm very confident that it's going to be a lot more easier. It'll be a lot more easier than what you imagine it to be. I'll tell you that much, because our imagination is the biggest enemy at this point of time. So trust me, it's going to be a lot more easier. So don't worry about that, right? That is what I want to say. Right, guys, so this is the marathon series where you will have the entire day full of sessions, all the way from biology that you've already done. Mariam's session, I'm hoping that it was, I'm pretty sure it was an amazing session. I saw the crowd, about 400 plus people were there in that session. Today we'll be doing all the 3 subjects, that is physics, physics, that is biology and chemistry as well. Biology is already done, physics is going on right now. Right after this, you'll also have chemistry sessions with Shilpi ma'am as well. In the days ahead, guys, according to your examinations, you'll also have mathematics on, it's divided as 2 separate sessions that'll be taken up by Harsh sir, and then you'll also have English sessions taken up by our very own Shweta ma'am and Amrit sir as well. Alright, Amit sir, sorry. Alright, so guys, let's get started. Without wasting any more of your time, let's begin today's session. Like I told you guys, I have about 25 questions in store for you guys. So we'll try to solve each and every one of those questions. I want you guys to give me 100%. Put down whatever answer you know in the chat box. I want you guys to spam the answer. It doesn't matter, but I want everyone to participate. Even if the other person is spamming, you also start spamming. Don't complain. You also start spamming, but you have to give me the answer in the chat box. All right. So can I get a oh yeah in the chat box if you guys are all ready? Unfortunately, there's no Menti because Menti would take a lot of time. So there's not going to be any Menti. We'll do it in the chat box itself because the only thing I want you guys to do is basically get some confidence regarding how to answer these questions. Right? All right, people. That's it. That is the spirit. All right. The first question, we're going to start with general MCQ questions, then we'll work our way through assertion reasoning type questions and your case study based questions also. The first question is this: which of the following statement is not true? Options are: a concave mirror can form a magnified virtual image, a convex mirror can form a magnified real image, a concave mirror can form a diminished real image, or a concave mirror can form a magnified virtual image. Which of these statements are not true? Now guys, when you're reading the question, make sure you give a lot of importance to these kind of things like not true or which is true, or you have to figure out which of the statements are correct or which of the statements are not correct. You have to pay a lot of attention to the question itself so that you don't end up losing marks in these silly questions. D. Why would you say D is the correct answer? Why can't you get in a concave mirror? Can't you get virtual magnified image? You can, right? B would be the answer, guys. Absolutely. Why D? It is option number B because in a convex mirror, you are always going to get a virtual image which is erect in nature, and more importantly, it is going to be diminished. That is the key word. It is going to be diminished. You will never get a real magnified image, or you'll never get a real image in general when it comes to convex mirrors. It's always going to be virtual, erect, and diminished. And without a doubt, that should be the answer. Anyone who says D and all, option A is the correct answer, because concave mirror can have a lot of varieties. It can form real as well as virtual image, but convex always virtual in nature. All right. Second question. Super easy. Second question. An object is placed at the center of curvature of a concave lens. The distance between the image and the pole is equal to 2f, greater than f but less than 2f, equal to f, or greater than 2f. If the object is placed exactly at the center of curvature in front of a concave lens, where, okay, it should be a concave mirror, guys, unfortunately. Okay, so a slight change. It can't be a concave lens. Let's make it as a concave mirror. All right, let's make it as a concave mirror. Let's not make it as a concave lens. Let's make it as a concave mirror. If it is a concave mirror, then what would be the distance between the image and the pole be? Absolutely right. Array, awesome. High five, people, everyone. That's it, guys. Super awesome. Proud of each and every one of you guys. Absolutely correct. No doubt. It is going to be equal to 2f. That is twice the focal length, or in other words, it is going to be exactly 2f is nothing but the radius of curvature, which is nothing but the image is going to be formed exactly at the center of curvature itself. Super duper easy question. Feeling a little bit more confident now? Yeah. Confidence rising up. ऊपर जा रहा है आपका confidence? Yes, no. All right. So again, guys, this is not a lens. Sorry, they're not talking about lens here. They're talking about the mirror. So please ignore the lens part. All right. Next question. The sky appears dark to passengers flying at very high altitudes, mainly because scattering of light is not enough at such heights. There is no atmosphere at great heights. The size of the molecules is smaller than the wavelength of visible light, or the light gets scattered towards the earth. What is the possible reason why the sky appears dark to passengers flying at very, very high altitudes? Let's go, guys. Come on. B. Why? Okay. B is like, okay. All right. All right. A or B? Make up your mind. Make up your mind. Make up your mind. All right. A lot of A and B is coming up. Okay, let me ask you this question, guys. Let me ask you this question. Imagine you have decided to go and climb Mount Everest. Do you think at that height there is no atmosphere at all? If you decide to climb the Mount Everest, is there no atmosphere at that height? That's my question. Is there no atmosphere? Yes or no, people? Simple yes or no wala question. Is there no atmosphere? Yes or no, da? Yes, no, there will be atmosphere, right? There will be atmosphere no matter what. It doesn't matter. There will be atmosphere. Just that the density of the atmosphere will be less. There will be lesser density. Because the density is less, there will be lesser scattering of light. So at that height, why does the sky appear black in color or dark in color? Is because there is less scattering. There is very, very less scattering of light happening, since there is not much dust particles or air particles at that height. Because guys, the thing is that because of the Earth's gravity, right, majority of the dust particles are near the Earth's surface itself. majority of the dust particles are near the Earth's surface. So as you go higher and higher, the density of air becomes lesser and lesser. This is the reason why mountaineers have to carry oxygen cylinders, because at that height, getting enough oxygen for your regular functioning becomes very, very difficult. So the answer is going to be option A, that is lesser scattering. It's not that there is no atmosphere, it's that there is very few scattering or very less scattering happening at that particular height. So the answer is going to be option A. Please don't forget that it's not that. See, if the question was why does the sky appear dark for astronauts, then you could have gone with option B. Then that makes sense, because in space, obviously, there is no atmosphere, so there is no scattering. So yes, option B would have been right. But here, when you're talking about high altitudes, there is atmosphere, but the density is very, very less. All right, fourth question. Guys, we have to hurry up a little because we don't have much time. So I'm going to rush a little. So here's the question. The danger signals installed at the top of tall buildings are red in color. These can be easily seen from a distance because among all the other colors, the red light is scattered the most by fog or smoke, is scattered the least by smoke or fog, is absorbed the most by smoke or fog, or moves fastest in the air. Very simple question. Come on, guys. Akka, absolutely. Murlidhar, check your answer. 100%. Super awesome, people. That's what I'm talking about exactly. Okay, can anyone tell me, okay, everyone in the chat box tell me what is the reason for this? What is the possible reason as to why option B is correct? Absolutely correct. That is red scatters the least. But what is the reason for it? Anyone in the chat box, please type out the reason also. What do you think is the reason why the red light scatters the least? Anyone? Super easy question, huh? What is the answer? The answer is definitely going to be option B. It scatters the least because red is exactly, guys, red has the highest wavelength, and hence, people, you can say that it basically does not scatter as much. It can travel a longer distance without scattering a lot. Super awesome, guys. Amazing, guys. It's good to see so many of you guys are giving the right answer. It is so good to see that side. All right, fifth question, guys. A ray of light is traveling from rarer medium to denser medium. From rarer medium to denser medium. While entering the denser medium at the point of incidence, it will go straight into the second medium. It bends towards the normal, it bends away from the normal, or it does not enter at all. If a ray of light is entering from a rare to dense medium, for example, from air to water or air to glass, will that ray go through straight without any deviation? It will bend towards the normal, away from the normal, or it does not enter at all. Super amazing, guys. Super duper amazing. Because I know time and again a lot of you guys make this mistakes, and I've seen it several times, even though I have repeated this a billion different times already. Please remember this, that when light is entering from rare to dense medium, it is going to bend towards the normal. It is going to bend towards the normal. On the other hand, when light is entering from dense to rare medium, it is going to bend away from normal. Away from normal. That's it. As simple as that. All right. So please do remember this, guys. Don't ever forget this. Don't ever get confused, because this is very, very basic. And more importantly, this is something that you can easily expect in your board exam. Not exactly in the same manner, but they might ask you in the form of an application-based question. So you have to be very clear about that ideology. All right, sixth question. Under which of the following conditions a concave mirror can form a real image larger than the actual object? Under which condition can a concave mirror form a real image larger than the actual object? Options are when the object is kept at a distance equal to the radius of curvature, when the object is kept at a distance less than the focal length, when the object is placed between the focus and the center of curvature, or when the object is placed at a distance greater than its radius of curvature. Think about all the ray diagrams that you've done in the past for concave mirrors and convex mirrors, concave lens and convex lens now, and try to figure out what do you think is the right answer. Super. Oh my god, guys, I can see the Josh. So much Josh you guys have. Guys, who is giving option B? Nirmala, check your answer. It has to be option number C. Absolutely spectacular job, guys. Because when the object, if you remember your ray diagram, when the object is placed between the focus and the center of curvature, the image that you're going to get is going to be real. And more importantly, it is going to be magnified. It's going to be larger than the object. And hence, guys, option C has to be the right answer over here. Super awesome, guys. Super awesome. Proud of you guys. So guys, let me ask you this question. Out of these 6 questions so far, how many of you have given all the 6 questions right? And again, be honest to yourself. Be honest to yourself. You don't have to lie to me. Be honest to yourself. Out of these 6 questions so far, how many of you guys have given all the questions correct? 100% all questions correct. No, sir, I have not made any mistakes at all. Yeah, awesome, da, awesome. That's what I'm talking about. Give me a high five, people. Yeah, high five, da. Come on, guys. Don't hesitate. It's okay. It's okay. High five. Da. Super awesome, guys. I hope that you continue to do the same thing. So that's 6 questions down, people. Moving on to the 7th question. An object is placed near a concave mirror at a distance of, now listen carefully guys, this is the question. An object is placed near a concave mirror at a distance of 1/4 of the radius of curvature, 1/4 of the radius of curvature of a concave mirror. Which ray diagram shows the incident ray, reflected ray, and the position and nature of the image formed? If an object is kept 1/4 the distance of the radius of curvature, where do you think the object position is going to be? And with respect to that, what will be your image position and nature of the image? Come on, people. Come on, come on, come on, come on. Come on, guys. Come on, da. Super awesome. Arre, smart guys. Arre, super awesome. That's what I'm talking about, people. So much Josh. My God, I'm also getting goosebumps looking at this. Super awesome, guys. Super awesome. Absolutely correct, guys. Absolutely correct. Let me give you an example. Imagine the radius of curvature of a particular mirror is given as 100 centimeter. If I divide this by 4, that's 25 centimeters. Now, if the radius of curvature is 100 centimeter, then the focal length would be what? 50 centimeter. So if the object is kept 1/4 of the radius of curvature, that means that the object distance around 25 centimeters, which means that what? It means that the object is placed between the focus and the pole. Super easy, guys. That's all. Simple mathematics, simple common sense, simple division. You're good to go. That's all. So the answer is definitely going to be option number A, no doubt. No doubts whatsoever. Super awesome, guys. All right, moving on to the 8th question now. 8th question, people. Here it is. An object at a distance of 15 centimeter is slowly moved towards the pole of a convex mirror. The image formed will become shortened and real, enlarged and real, enlarged and virtual, or virtual and diminished. Now, 2 things I want you guys to focus on is this. 1 is the object distance. 2nd, it's a convex mirror. If it is a convex mirror and you're bringing it closer and closer, what would happen to that image? Will it shorten and real? Would it become enlarged and real? Would it become enlarged and virtual, or virtual and diminished? Come on, people. Exactly, Christy. Super awesome, guys. That is what I'm talking about. Wonderful job. Exactly correct. Because it's a convex mirror. In a convex mirror, no matter where the object is kept, even if it's at infinity or near the pole of that particular mirror, it doesn't matter. The image will always be virtual. It will always be erect and always be diminished. Don't ever forget this, guys. For a convex mirror and a concave lens, it's the same thing. It's always going to be virtual, diminished, erect, no matter where you keep it. So doesn't matter where you keep it. It's going to be option number D, virtual and diminished. That's all. All right. Super awesome, guys. Well done, well done. So that would be the answer for the 8th question. Moving on to the 9th question now. Almost 20 minutes in, and we're going to go to the 9th question. So I'm, feeling confident that we'll be able to finish it on time. Select the correct statement from the statements given below regarding the use of convex mirror as rear view mirror. In simple words, they're asking you, why do you use convex mirrors as rear view mirrors? First statement is, convex mirror always forms a virtual and erect image. Statement 2 is, convex mirrors may form real or virtual image depending on the position of the object. Statement 3 is, images formed by a convex mirror are always or usually larger than the object. And statement 4 is, convex mirror provides a wider field of view as they are curved outwards. Which of these statements are correct? Options are both 1 and 2 are correct, both 2 and 3 are correct, both 1 and 4 are correct, or both 3 and 4 are correct. Come on, guys, think about it. Super easy question. Arre, Christy, check the answer. Anyone else? Pakka? Everyone? Option C. Check. Yes, Kenny, Malayali. Alright, quickly, guys, quickly. Exactly, people, everyone. Arre, super awesome, guys. Once again, You guys are doing amazingly well, amazingly well. Now again, people, if you are making mistakes, see, this is what I want to say, that a lot of you guys are giving the right answer. So you also don't join them and give the right answer. You think by yourself using your own brains and try to give the answer, because ultimately, guys, in your examination, none of your friends are going to be with you. You can't expect that I'll go with, go with whatever the majority is going with. So please think and give the answer. Even if it's wrong, be honest to yourself. Accept that it's a mistake and then try to correct it before, in the next couple of hours, so that you don't repeat the same mistakes tomorrow, right? Very important that you do that, right? Anyways, the answer is going to be definitely option number C, guys. Definitely convex mirror forms always virtual and direct image, and also it has a wider field of view because it is curved outwards, so you can basically see the entire left side and the right side of that particular route. So that is the answer, guys. Super awesome. Well done. Moving on to the 10th question, guys. 10th question on your screens. Here it is. 4 students studied refractive of light through a glass prism. Refraction of light through a glass prism. They traced the rays of light and measured the angle of incidence I and the angle of deviation capital D, as shown in the figure. A, B, C, D. There are 4 different triangles, or basically it's the same prism. You have to figure out which one has been correctly represented in terms of angle of incidence and angle of deviation. In which of the 4 diagrams angle of incidence and angle of deviation is rightly mentioned? That is the question. It's something that, it sounds like a very difficult question, but it's actually very, very, very simple. Super easy question it is. So let's go. Oh, hi, Manasveer ji, what's up? Long time no see. How are you doing? Super awesome. See, Kokila, check the answer. See, Pakka. Okay, why are you guys going with C over here? Okay, all right. Okay, see guys, it's very simple. If I have a triangle, or if I have a prism for that matter, if this is my incident ray, this is my normal here. Now, what is the definition of angle of incidence? It is the angle formed between the incident ray and the normal. So, once again think, can it be option number C now? Because the angle between the incident ray and the normal is called as angle of incidence, not with the prism. Here the angle is formed with the prism. So that cannot be the right answer. So it has to be either option A, B or C. Now to talk about angle of deviation. So this ray of light will undergo refraction, and then again it's going to come out of this prism. If I extend my incident ray and my emergent ray, the angle formed between them, that is called as angle of deviation, which is represented by delta or capital D. So the answer has to be option A and not option C. Guys, again, very simple question, but I saw that a lot of you guys made that mistake. Why? Because you're taking it to easier times. There's something called overconfidence. That is what is happening. So pay attention. That is what I'm telling you. All these small details, that is where you get the wrong answer. Because what is going to happen is that you will assume that you know the answer and you'll directly jump into it. So try to slow down a little. It's okay to give it slow, give the answer slow. You have 1 hour, 30 minutes time. There's no need for you to rush, but you need to get it right. Because ultimately, what your invigilator is worried about, the person who corrects the paper, they only care about if the answer is correct or not. They will not check whether you answer the question in 30 seconds or 15 seconds. It doesn't matter. What you give is what is mattering. So make sure that you pay attention to the questions very, very carefully. When you're given that first 20 minutes, read the question very thoroughly. All right, do not miss it out. All right, 11th question. That is my simple tip of the day, I would say. 11th question. 2 identical prisms, PQR and P-Q' and R' are given. White light passes through PQR as shown in the figure. Which of the following positions of P', Q' and R' will again yield you a white light? So you can see this, guys. White light is entering through a prism and it is getting split into 7 different colors, also known as dispersion. Now, if there is another prism given, which is identical in nature, same refractive index, everything is the same angle of prism, everything is the same. In which orientation should I place that other prism in order to get white light? That is the question. A, B, C, or D. Super easy question now. Super easy question. Amazing, people, amazing. That's what I'm talking about, guys. Super duper awesome. This is how Newton proved that white light is a combination of 7 different colors. When light passes through a prism, yes, it undergoes dispersion. But if you have an inverted prism like this, when that dispersed light enters into that prism, what happens is that it gets reversed or negated and it comes out as white light. And hence, people, without any speck of doubt, the answer has to be option number B without any doubts. All right, it has to be option B and nothing else. It has to be inverted. All right, now one of the conditions you have to notice if they ever ask you why this is happening is because the reason, just to as an extra information, these two surfaces are parallel to each other. You have to make it you have to do it such a way that those two refracting surfaces are parallel to each other. Only then you will get it as white light. Otherwise there'll be there you will get basically some sort of dispersion happening. All right, okay, 12th question, guys. I think the 12th question, people. Finally, after a very long time, you're getting into the numericals right now. So let's get into the numericals. Now, from now on, people, you're going to find a lot of numericals in the session. So whoever does not have your notebooks and pen with you, I'm sure many of you guys are sitting in front of the computers or screen, chilling with your hands right now. So go get your pens and papers. I'll give you 30 seconds because we're going to do a lot of numericals right now. In the rest of the session that we have, there'll be a lot of numericals being solved. So get your pens and papers, try out each and every numerical. If you are feeling stuck somewhere, let me know so that I can show the calculation as well. But don't hesitate, try your best. All right, here's the question. Sunil conducts an activity using an object of height 10 centimeter and a convex mirror of focal length 20 centimeters. What is given? He placed the object at a distance of 20 centimeters in front of a mirror. What is likely to be the height of the image produced? Options are -5 centimeters, 5 centimeters, 1 centimeter, or 20 centimeters. Let's go, people. Come on. I know, Nitiji. That's why I'm telling you. Take your time, but you need to give me the right answer here. All right, because these are numericals, guys, and numericals are very, very important for your board exam. Super duper important for your term 1 examination. You need to be quick with your calculation. You need to be more precise, and more importantly, you cannot find, there are no shortcuts for it. You have to do it, unlike your theory part. All right. Awesome, people. Okay, B, a lot of answers. A, B, C, or any other. Why is option D not selected? There is discrimination for option D. We want justice. Pakka, 5 centimeters, 100%. Pakka. Are super awesome, guys. Exactly. Now the answer is going to be option number B. Let me tell you why. How to solve this question. It's actually quite simple, guys. Okay, so I'm just going to write it over here itself. Height of the object is given as 10 centimeter. All right. The focal length, it's a convex mirror, so it's going to be positive. So focal length is going to be plus 20 centimeter. Now remember the sign convention, guys. This is where majority go wrong. So please remember the sign convention as well. I'm going to show this one numerical very, in detail. The rest of the numericals, I'm going to show it very, haphazard. So basically, I will try to do it fast because we don't have much time, right? Okay, object distance U is given as 20 centimeter, but it's going to be -20 centimeter. You have to find out what, what is the height of the image. First thing first, guys, you need to find out the image distance. All right, so what is the formula? 1 by V plus 1 by U is equal to 1 by F is basically the formula. Put the values here. -1 by 20 is equal to 1 by 20. Take that to the other side. So I'm just gonna write, guys, I'm gonna continue that in the next this thing. So 1 by V minus 1 by 20 is equal to 1 by 20 is what I have. I'm taking this to the other side. So 1 by V is equal to 1 by 20 plus 1 by 20. That makes it 2 by 20 is equal to 1 by V. So V is equal to 10 centimeters. Simple. Reciprocal of that. So this is going to be V is equal to 20 by 2, which is nothing but 10 centimeters. Simple. Now use the magnification formula. M is equal to minus V by U. So V is given as -10 centimeters. So -10 divided by -20. So that is the object distance, -20. So what will you get? You will get the magnification as basically 0.5. Now this, put that in the second equation of magnification. I know it's a long problem, but it's a very small numerical, very, very small numericals. So M is also equal to HI by HO. 0.5 is equal to height of the image. Height of the object is given as 10. So take that to the other side. So you'll get it as 5 centimeter. So yes, that's it. Very simple. Exactly. Very small. Super duper. Like it's like a cute little baby, like a 6-month-old baby. That's a very small numerical. You can get it done. All right. But again, guys, the calculation is not that difficult. The calculation is not that difficult. It's just that you need to, it's going to be a little longer, but the calculation is not difficult. Rather than doing it this way, you can also shorten the steps by doing it this way as well. M is equal to HI by HO, which is equal to minus V by U. So directly you can use this and get the answer. That is also perfectly fine. Rather than doing it separately, you can do it this way also. That will save you a lot of time. So you can do that way also. Right, guys? So the answer anyways is going to be 5 centimeter. Next question, 13th question. Here we go. An image of an object is produced on the screen, which is about 36 centimeters using a convex lens. The image produced is 3 times the size of the object. What is the distance of the object? Options are 12 centimeters, minus 12 centimeters, 33 centimeters, or 39 centimeters. All right, go ahead, guys. Come on, give me the answer. So can you please tell what happens when the object moves closer to a convex lens? It doesn't matter. Okay, you mean, okay, it'll come closer to the lens. As you bring the object closer and closer, in a convex lens, so it goes further and further away. As you bring the object closer and closer, it'll move further and further away. But once you cross the focal length, then the image is going to be formed on the same side. That's all. All right, let's go, guys. Let's go. Super easy. B or C? B, C, A. No, again, option D is nobody. Why option D is so discriminated? I don't understand this. What did option D do to you guys? I don't understand that. All right, Pakka. 100%. All right, let's see. Guys, okay, here's the thing, guys. It's a convex lens. All right. The image produced is at a distance of 36 centimeter. The magnification is given as 3 times. So first thing, guys, again for here also, image distance is given as 36 centimeter. It's going to be plus 36 because it's a real image. Magnification is given as minus 3. Now, first of all, guys, how many of you guys did not take it as minus 3? Tell me honestly, how many of you guys did not take it as minus 3? Because I'm pretty sure that a lot of you guys have made this mistake over here. Guys, remember this. If it is a real image, magnification is going to be negative. If it is a virtual image, please remember this, magnification is going to be positive. This is true for both concave mirrors and concave convex lenses also. It is true for lenses as well as mirrors. So don't ever forget this. Real images, magnification will be minus. For virtual image, it is always going to be positive. Now that you know this, guys, we know that M is equal to what? M is equal to V by U is the formula for magnification. So here M is minus 3, which is equal to 36 divided by U. So U is equal to 36 divided by 3, which is nothing but 12 centimeters, minus 12 centimeters. That's all. Super easy question. Like this is like bacha level question. This is bacha level question. Is that clear? That's all, people. You don't have to do anything. That's a two-step numerical and you're done. You just need to remember the formula, and more importantly, you need to take the sign convention right. That is why I see that a lot of you guys gone with option number A. It is not correct. Why? Because it's a real image. For real image, magnification is always negative. So don't ever forget this. Don't ever forget this. Do you want a small small recap of this? How many of you guys want me to basically write about the sign convention very quickly? Very quickly. If you guys want a quick revision for that, I can do it. If you guys want it. Otherwise, I'll go to the next question. Pakka? Alright, I want majority. If the majority is saying yes, then I can go with it. Otherwise, I'll go to the next question. Alright? Quickly. All right, I'll just very quickly write it down, guys. Please note it down if you want to. So, okay, let me just create a new slide. Hold on for 1 second, people. Let me just create a new slide. Okay, hold on, guys. I'll just create a new slide. Give me 1 second. All right, 1 sec. Okay, so here's the thing, guys. Please remember this. Very important. When it comes to the sign convention, all right, I'm going to write for lenses for now. Sign convention for lenses. All right, please remember this. You have concave lens and convex lens. Very quickly, guys, I'll just write it down very quickly. Very important, so you can note it down. Focal length for concave lens is always negative. For concave lens, it's negative. Focal length for convex is going to be positive. First thing. If you talk about the power of a concave lens is going to be negative. Power of a convex lens is going to be positive. Please remember all these things. Very, very important. Magnification. Since concave mirror always forms a virtual image, magnification will be positive. But in a convex lens, guys, you can get both real and virtual image. So if it's a real image, it is going to be negative. If it is a virtual image, it is going to be positive. When it comes to object distance, for both, it is going to be negative. Object distance for everything is going to be negative, so you don't have to worry about it. Don't have to get it confused. Image distance for concave mirror, because it always forms a virtual image, will be negative because it forms virtual image. But for convex lens, if it forms a real image, then it's going to be positive. If it is a virtual image, then it is going to be negative. Please remember this, guys. Please remember this. This is something that you guys would find it super duper helpful, and something that you can use for every numerical that you have. All right, every single numerical, you guys can use this and check if the answer that you're going to get is matching with this or not. Super important. So please do this. Please do this. All right. Take a screenshot of this one and keep it with you guys. All right. Exactly, guys. Sign convention. This is all the sign conventions. This is all the sign convention for lenses. Again, this is for lenses. For mirrors, it's going to be different. This is only for lenses. For mirrors, it's going to be a little different. All right. Exactly. Always virtual. Now, Kalika, for concave lens always forms a virtual image, so it is always going to be positive. The image distance will be image differences will always be negative. Right. For concave mirror, it will be negative if it is a real image. All right, there's a lot of difference between lenses and mirrors, but please do remember this. All right, exactly. All right, both for, see guys, that is what I'm trying to tell you. For convex lens, depending on what type of image, if it is real image, negative, virtual image, positive. When it comes to magnification, when it comes to image distance, real image is going to be basically positive, and virtual image is going to be negative. It depends on that. All right, moving on to the next question, guys. Moving on to the next question. I hope it's clear now. Next question. Here's the 14th question. A concave mirror of focal length 20 centimeter forms an image having twice the size of the object. For the virtual position of the image, the position of the object will be what? Now, trust me, guys, this question, you don't even have to do the calculation. You can easily get the answer. The focal length of the concave mirror is given. They're telling me the magnification is twice the size of the object. All right. It is a virtual image. Options are 25 centimeters, 40 centimeters, 10 centimeters, or infinity. Super easy. Super duper easy. Tell for mirrors also. I'll write it towards the end. I'll write it for mirrors as well, guys. Towards the end, please remind me. I'll write the sign convention for mirrors also. Don't worry. All right. Yeah, the session PDF will be available, but I would suggest you guys, because the session PDF will be uploaded later on. It would be better if you can take the screenshot and keep it with you. That would save your time, because when you're doing the questions, it'll be a lot more helpful for you guys. All right. Okay, I feel like laughing for that, because guys, I'm getting all the answers. Again, 25 centimeters, 40 centimeters, 10 centimeters, infinity, everything is being chosen. So, okay, but here's the thing, guys. Here's the thing now. This one is very easy. Let me tell you why. See, guys, it's a concave mirror. Just draw the ray diagram. That's it. Just draw the ray diagram. Focal length is 20 centimeter. Awesome. Focal length is 20 centimeter. Super duper awesome. Now, in which object position will you get a virtual image? In which object position will you get a virtual image? Where should you keep an object in order for you to get a virtual image for a concave mirror? Where? Exactly between the focus and the pole. So 25 centimeters cannot be the right answer because it's greater than the focal length. 40 centimeters cannot be the right answer. The only answer that is possible is option C. That's it. Zero calculation, correct answer. That's all. That is why I'm telling you people, if you know your ray diagrams, you don't have to do this. You have basically saved yourself of 5 minutes time to calculate all this. Rather than doing all of this and ending up with the same answer, you can do it in 30 seconds just by knowing your ray diagrams. This is called as a verification method. So please practice this. All right, please practice this so you can save a lot of time, guys. Out of 90 minutes, you're able to save 5 minutes without having to do. Again, if you want to go with the normal formula method, this is the same formula: 1 by v plus 1 by u is equal to 1 by f. Substitute the values, get the answer. Otherwise, you can just use this and get the answer. That's all. All right, next question, guys. Next question. So people, do you want me to show you the calculation for this one? I'm pretty sure you guys are aware of the calculation, right? I'm pretty sure everyone is aware of this one, right? How to do the calculation part, I'm pretty sure you know this, but anyways, I'm going to put it out. I'll just write on the steps over here. So image is given, magnification is given as twice the size, so it's going to be 2 plus 2 again, and focal length is given as 20 centimeter. So what you can do is, guys, use the magnification formula m is equal to minus v by u, and take the value for u here. So you can see that, v here. V is equal to minus 2u. Now what you do is that use your mirror formula. 1 by v plus 1 by u is equal to 1 by f. Sorry for that. One sec. Okay, I have to erase this part. Hold on. Oh my god. Okay, how do I undo this? Oh, it's not possible. Okay, people, so you guys know the answer, but I'm going to do it anyways. I'll just quickly do it one more time. Unfortunately, I erase the whole thing because I'm a genius. So anyways, focal length is given as 20 centimeter, guys. Magnification, it's a concave mirror, so it's going to be minus. Magnification is given as plus 2. So use the formula m is equal to minus v by u. Find the value for v here. So 2u is equal, minus 2u is equal to v. Use your mirror formula. 1 by v plus 1 by u is equal to 1 by f. Use that, substitute that over here. minus 2u plus u is equal to 1 by minus 20. Find out the LCM into 2 into 2, get the answer. All right, this is how you're going to get the object distance. Once you get the object distance, you will be able to find out the answer. That's it. This is one way to do it. All right. Anyways, moving on to the next question. It's 15th question. All right, 10 more questions to go through. Let's finish it off very quickly. All right, 15th question, guys. 15th question. To form an image twice the size of the object using a convex lens of focal length 20 centimeter, what should be the object distance? Options are less than 20 centimeters, greater than 40 centimeters, between 20 and 40 centimeters, or none of the above. Now again, people, if you're confused about this question, use your ray diagrams. Draw your ray diagrams. Do a rough ray diagram. Even if it does not look like a ray diagram, as long as you're able to understand that it's a ray diagram, do it. But you have to use your ray diagrams if you're feeling confused and get the answer. Come on, guys. Super easy question. B or C? Make up your mind. Is it going to be B or C? Now, look at the question. The focal length is given as 20 centimeter, right? It's a convex lens. Focal length is given as 20 centimeter. So twice the focal length is going to be 40 centimeter. So where should you keep the object in order for you to get a magnified image which is twice the size of the object? Exactly, people. It cannot be. See, guys, see, here's the thing. If the object is kept, see, it's a convex lens. If the object is placed between f1 and 2f1, then and only then will you get a magnified image beyond 2f2. All right, so the answer has to be option number C, guys. Again, simple ray diagram. So the answer is going to be option number C. Again, remember your ray diagrams, because guys, you remember this, that see, when the object is placed at 2f2, the image is going to be formed exactly at 2f1. It will be of the same size. If you go beyond 2f2, when you keep the object between 2f2 or 2f1, sorry, between 2f1 and f1, the image is going to be magnified, real, and inverted. And so the object has to be kept between 20 and 40 centimeters in order for you to get a magnified image which is twice the size. Is that clear, guys? Understood? Super duper easy. Able. Why not option A? If you keep it less than 20 centimeters, you are going to get a virtual image, Noda. You're going to get a virtual image. You're going to get a virtual image. It can actually be to some, because they have not mentioned it nonetheless. They have not mentioned it, but we are assuming that it is going to be a real image. But yeah, it can actually be option A also. If in case if they had mentioned it as virtual image, then you could have gone with option number A as well. But since they've mentioned it, I'm assuming that it's a real image and it's magnified. So I'm going to go with option number C here. All right. So guys, that is the answer for that particular question. Now, before we go to the 15th question, how are you guys feeling? How are you guys feeling? How's the Josh right now? Going up or down? What is it? What is running through your head? Are you guys feeling that the exam is going to be easier or it's going to be more difficult after looking at these questions? Screen is blurred, is it? Like, why? Why is the screen blurred? I think you have to adjust the resolution or something. Try to increase the quality of the image, something like that. I don't know. I'll just check it once. Give me 1 second, people. Is the screen blurred for all of you guys? No, right? No, it's not blurred. Huh? Hi or good? Easier? Tough? Bored? What to do now? What to do? Examinations. Yeah, sure. I'll do for mirrors also. Don't worry. Confused? More confused? All right. But anyways, guys, I'm hoping that it's helping. I'm hoping that that is helping. Okay, one more question. Out of 15 questions, how many of you guys have gotten how many questions right so far? How many of you guys have gotten all the questions right? And how many of you guys gotten, with respect to that, how many questions do you get? 10 questions, 5 questions, 7 questions, 8 questions. Getting confused? Why, Christy G? Tell me, what is the confusion here? I'll take up your doubts also. Don't worry. Easier, moderate, blurred. Is still blurred? Why is it blurred? I'm getting a clear image. No, I'm getting... Okay, do I look blurred? No, right? 14, 10, 12, 10, 13, 14, 15. Awesome. Super awesome, people. 12, 13, 14. Awesome. I'm proud of you guys. Absolutely wonderful. Keep up the good job, guys. Keep continuing to do the same thing. Do not slow down now. It's not time for you to take rest. You have to keep going. Moving on to the 16th question now. Here it is. A convex lens of focal length 20 centimeter and a concave lens B of focal length 5 centimeter are kept along the same axis with a distance D between them. If a parallel beam of light is falling on A, leaves B as a parallel beam, then what should be the distance D between A and B? That is the question. Options are 25 centimeters, 15 centimeters, 30 centimeters, or 50 centimeter. Oh, hi Sohan, what's up now? How are you doing? Long time no see. How are you doing? Welcome. How are you people doing? Come on, guys. Come on. What do you think is the right answer for this one? This is by far one of the most weirdest question that you're going to get. One of the most weirdest question that you can get in this, in this entire 25 questions that I have in store for you guys. This is one of the most weirdest question because it is not something that you see very regularly in your NCRT or in your CBSE board examination, but it's something which is which is a hot kind of question, like higher order thinking question. Okay, so here's the thing, guys. Super awesome. Are so many of you guys are giving the right answer. Amazing, guys. Oh my god. Clarity, what is that? Who's that? Crafty, check your answer. But exactly, guys, the right answer is going to be option number B. Let me tell you why. First, guys, A is a convex mirror. It's a convex mirror of focal length 20 centimeter. So imagine this is the principal axis. It's on 20 centimeter. I'm going to assume this is 20 centimeter. So focal length is 20 centimeter. I have another lens which is basically a concave lens, and that has a focal length of 5 centimeter. So here's the condition, guys. I need to get the image coming out of this particular lens to be parallel to each other. Now, in order to do so, where should I keep the second lens is the question. I hope it's understood. Did you guys understand the question first, people? Can I get a yes if you've understood the question? Have you guys understood the question? You need to make sure that the lens, the ray of light that is coming out from the second lens has to be parallel to each other. That is the question here. So listen carefully. What are you supposed to do? See, guys, we know one thing, that when a ray of light is parallel to the principal axis, after refraction, when it's passing through a convex lens, it will always pass through the focus. It'll always pass through the focus. If it's a parallel beam of light, then after refraction, this ray of light is going to pass through the focus. Now that is the focus is right there. Now what I'm going to do is I am going to place my concave lens 5 centimeters before the focal length. Let me tell you why. Because the focal length of this lens is 5 centimeter. The focal length of the second lens is 5 centimeters. So here's what is going to happen. The ray of light that was supposed to pass through the focus now only appears to pass through the focus. So what will happen is that the ray diagram would look something like this. So this was initially supposed to pass through the focus, but according to the standard incident ray of a concave lens, guys, if you have a ray of light passing or appearing to pass through the center of curvature, after refraction, that ray of light is going to become parallel to the principal axis. So the answer should be B. It has to be kept at 15 centimeters. The distance between the two lenses has to be 15 centimeters so that the refracted rays appearing to pass through the focus such a way that the ray of light that is coming out is going to be parallel to each other. Is that clear, guys? Understood? This is one of the weirdest question that you can be asked, that can be asked in your, in the entire of 25 questions that I have for you guys. This is by far the weirdest question. Is that clear? Pakka? That's solved. Super duper easy. You just need to make sure that the second lens, that is the concave lens, has to be placed a little bit before so that the ray of light that is supposed to go to the focus now undergoes refraction and becomes parallel to the principal axis. That's it. So that would be the answer for this question. Super duper easy, no? That's a no. Bacha question. Again, guys, I can't speak in Hindi because my Hindi is as good as Ja Simran Ja Ji Le Apni Zindagi. That's all. Alright. If you want me to teach the entire session in Ja Simran Ja Ji Le Apni Zindagi, I can teach in Hindi. But if you don't want that to happen, then please understand that my Hindi is hopelessly bad. If I start speaking in Hindi, you will forget the Hindi that you know. So please understand that is the case and bear with me. That's all I can say. Alright. Here is another one. 17th question, guys. 17th question. A student conducts an experiment using a convex lens. He places the object at a distance 60 centimeters in front of the lens and observes that the image formed is at a distance of 30 centimeters behind the lens. What is the power of the lens? Pacha question. Options are 0.005 diopter, 50 diopter, 5 diopter or 0.05 diopter. Let's go, guys. Let's go. Guys, again, I wish I could speak in Hindi, but unfortunately my Hindi is hopelessly bad. I'm telling you, it's hopelessly bad. When I say hopelessly bad, my Hindi, like I told you, I can just say खाना दे दो, पानी दे दो, जा सिमरन जा जी ले अपनी जिंदगी without making mistakes. All right. So unfortunately, that is all I can do. All right. I know. I'm hopeless. I studied Hindi for 12 years, but I still can't speak Hindi. So that's how awesome I am. All right. Video is not clear. Hold on for 1 second, guys. Let me just check the preview. 1 second. Hold on, guys. 1 second. All right. 1 second. Let me just check. What is the issue here? Hold on, people. Is it clear now? 1 sec. Let me just check if the camera is clear or not. Hold on. Is it clear now? I know there are a lot of non-Hindi students here, but what to do? I can't learn the language in 30 minutes. No, that's fine. Clear, no? All right. Quickly, guys, what do you think is the right answer? Let's go. What is the right answer? Option number A, 0.005 diopter. Option B is 50 diopter. Option C is 5 diopter. Option D, 0.05 diopter. Let's go. Exactly. Increase your video quality, guys. I have a clear preview as well. I'm hoping that you guys also have a clear preview. Let's go. Come on, quickly. Come on. C, option D, DC Comics. No normal universe. What is this? Okay. Alright, guys, very simple. Let me tell you how to do this. First thing, guys, you need to find out the focal length. It's a convex lens, right? Object distance is going to be minus 60 centimeter. Simple. Image distance V is going to be plus 30 centimeter because it's formed on the other side, alright, behind the lens. So it's going to be plus 30 centimeter. First thing first, find out the focal length. So 1 by V minus 1 by U is equal to 1 by F is the formula. So 1 by 30 minus of minus 60 is equal to 1 by F, which is nothing but plus 60. So into 2, finding out the LCM. So 2 plus 1 divided by 60 is equal to 1 by F. So F is going to be 3 by 20 centimeters. Sorry, F is going to be 20 centimeter. All right, F is going to be 20 centimeters. Why? Because it's going to be 3 by 60, which is equal to 1 by F. So F is 60 by 3, which is nothing but 20 centimeter. First thing that you need to do is you need to change the focal length to meters. Focal length that you got was 20 centimeters. So convert this to meters, divide this by 100. So 0.2 meters. Now use the formula power is equal to 1 by F. So power is equal to 1 by 0.2 multiply with 10 with 10. So 10 by 2, which is nothing but 5 diopter. Okay, tell me how many of you guys did not convert from centimeters to meter? Tell me honestly, how many of you guys did not convert centimeters to meters here? I knew it. Oh, you did, Ashwat. Awesome. Thank you, Jay. Awesome. This is the mistake, guys. See, people, you need to remember this one very important point, that if you want to find out the power of a lens in terms of diopters, you need to make sure that the focal length is given as meters. If not, if you want to do it in terms of centimeter itself, then the formula, instead of 1 by F, you can take it as P is equal to 100 by F. If you want to keep it as 1 by, if you don't want to convert it to meters and you want to do it in centimeters itself, then please remember this, that the power of the lens, the formula will become 100 by F and not 1 by F. That is the only difference. Alright, that is the only difference. So if you want to keep it that way itself, do it 100 by F. If not, you want to convert to meters, then use the formula P is equal to 1 by F. So that is the difference. So whichever way you want to do it, but make sure you keep an eye on the unit. Otherwise, you'll end up making the same mistakes in your board exam also. So the answer for this question is going to be 5 diopter. Alright guys, 18th question. My God, nearing the end. Here's the question. The ray diagram shows the refraction of light as light passes from air. The refractive index of air is given as 1.0003. To turpentine, which is another, it's a chemical that is used for wood polish and all that. The refractive index of turpentine is given as 1.47. And then it is entering into water, which has a refractive index of 1.33. 4 ray diagrams have been shown or has been drawn here, labeled as 1, 2, 3, 4. Which would be the correct path of light as the light enters from air to turpentine to water? Come on guys, very easy question. If you know the basic concept of how light is going to behave when it's entering from rarer to denser medium or denser to rarer medium, that is all you need to remember. If you know that, this by far is going to be one of the most easiest questions that you're going to ever attempt. So go ahead guys, come on. What do you think is the answer? Hi Ansh, what's up da? Yes, B, A, B. What do you guys, make up your mind da? 2, Pakka, 4. All right, Krishnananda, what's up? How are you doing? Second, A, B. Okay, A and B are widely chosen. The answer, guys, unfortunately, is option B. Let me tell you why. See, guys, initially, light is entering from air to turpentine. So, in comparison, air is a rarer medium and turpentine is a denser medium. So it's going to slightly bend towards a normal. You can see that it's not exactly a straight line, it's slightly bending towards a normal. All right. Again, it is not that evident, but it is slightly bending. Now, second of all, when you talk about the second medium, light is entering from denser medium, that is turpentine to water, basically turpentine to water. Now, in comparison, water is a rarer medium to turpentine. Why? Because the refractive index of turpentine is 1.47 and that of water is 1.33. So in comparison, turpentine is more denser and water is more rarer. So when light is entering from denser to rarer medium, it is going to bend away from normal, and hence, guys, option 2 would be the right answer. Not option A, not option C, because in C though it's going through a straight line. Not option 4 also, because here they're showing that it is entering from denser to rarer medium. So here they're saying that air is more denser than turpentine, which is definitely not the case, and hence option 2 should be the right answer here. So without a doubt, the answer should be option 2. Is everyone clear with this, guys? Is everyone clear? Turpentine is basically a very, very dense chemical that is used for polishing and stuff. It is used to remove paint. It is used to, polish wood. It is used in a lot of different places. In hardware shops, and all you can see, turpentine is a different kind of chemical. It's a very, very thick, dense chemical. All right, so it has a much more higher density. Viscosity is high, or density is very high, and hence it has a much higher refractive index of 1.47. All right, okay, people. All right. Finally, we are done with MCQs. That's it. Done and dusted. Now, people, we are going to get into assertion reasoning type questions. So before we get started, let me ask this question one more time. How's the Josh, people? How's the Josh? High, low, super high, super low. What is happening inside your heads? Please tell me. Yeah, sure. You need to do Sonji. Yes, you need to remember refractive index also. It's very, very important. Yeah, I know. It's not that evident over here, guys. It is not that evident. It is very slightly given. It is ever so slightly given. But the main thing is that you need to look at this one. Here it's very clear that light is entering from denser to rarer medium. That is why it's going away from the normal. So that is why option 2 is more accurate than the rest of it. All right. Okay, so guys, how's the Josh? Yeah. Super high, high, low, low. Why low? Why low? Exam is tomorrow. You have to keep it high. You have to. There's no choice. You have to set yourself on, not literal fire, but you have to be on fire. Exactly. All right. So people, here is your assertion reasoning type questions. Now you guys know the drill for assertion reasoning type questions. You'll be given 2 statements. One is called as the assertion. The other is called as the reason. You have to first figure out whether the statements given are true or false. Second step is you have to figure out whether the answer or the reason supports the assertion or not. But before that, guys, like I told you, I have a surprise for you guys. All right, I have a surprise. Don't leave it. I have a surprise for you guys. So I am going to introduce a personality here for you guys. All right, one amazing personality to keep this Josh high. All right, just give me a second, guys. Let me invite that amazing personality here. Just give me 1 second. Unfortunately, yes, here it is. Hold on for 1 second, guys. Hold on for 1 second. So this person, you can guess whoever that person is. I know I have to comb my hair. I have to get a haircut first. So yeah, it looks disgusting, but don't get scared. Anyways, so as I was saying, guys, this amazing personality of the century is gonna appear on your screens right now. Just give me a second. Unfortunately, this person is not here yet. So I am going to, wait. Okay, not wait. Let's go ahead. As soon as the personality joins, we will, we will invite that person as well. All right. So, okay. Anyways, let's get back to the questions. In the meanwhile, I'm just gonna minimize this. Hold on, guys. Yes. Where is it? Where is my yes? Okay. I hope you guys can see the screen at least. No, you guys are able to see the screen, right? Hold on for 1 second, guys. I have to do some settings and stuff. Unfortunately, I have not. One sec. Yes. Oh yeah. Yes. Sorry for that. Yes. Use the video. Thank you. Yes. All right. So people, I'm going to invite that personality in a minute. She's going to be here. Okay, she or he is going to be here in any second now to motivate you guys a lot more. So with that said, people, let's get on to the next type of questions. Until that person joins, let's get into assertion reasoning type questions. Now, here's the first one, guys. So here, guys, I'm going to ask you a couple of questions from Human and Colorful World also. So be ready for that as well. So here's the question. A ray of light incidents obliquely on the face of a rectangular glass prism placed in air emerges from the opposite side parallel to the incident ray. Reason is lateral displacement depends on the angle of incidence, the thickness of the slab, and refractive index of the material. What do you think is the right answer? Oh, I'm lagging. Oh, is it? Okay, 1 second. Am I lagging too much? Okay, hold on, guys, hold on. Am I lagging way too much, or is it okay kind of lag? Hold on. I don't know why every time I do this, it lags. I don't know what is the reason for that. Okay, just give me a second, guys. I'll see what is the problem exactly. All right. Is it lagging way too much? No, right? You guys can still hear me and see me. No, hold on, guys. 1 second. All right. I don't know what is the problem. Give me 1 second, guys. 1 second. Okay. Is it better now? All right, better now. No? All right, thank you guys. Thank you. All right, so let's go, people. That person is going to join. I'm not going to reveal the secret. All right, yes. And yeah, the person is finally here. All right, so guys, I would like to welcome you all, our very own Miss Bhavna ma'am. Oh, sorry, Mrs. Bhavna ma'am.
Oh my
Bhavna
God.
ma'am,
Thank you very much.
what's up?
Thank you. Thank you. I heard
Okay,
it.
so I've done so much intro I've given for you, know, so much hype I've created. So
I was seeing your sessions. Because sir, I know everything.
all right, so guys, yes, please say hi to Bhavna ma'am. Yes, please.
Okay. Hi, people. A very, very warm welcome to me. Obviously, you guys are linked with Anoop Sir for so many questions. I've seen that you have done all your MCQs and now you're into assertion reasoning. तो मैंने सोचा चलो मैं भी जाके थोड़ा सा बातचीत करके आती हूँ. The thing that Anoop Sir is very bad with Hindi. I will cope up with that stuff.
Exactly.
So yeah.
All right, so
People,
ma'am, please, you do the honors. I'll also take some rest now. In the meantime, you
do
can.
the honors.
Yes. Please do the
Yeah,
honors.
I am a physics honors. So yeah, people, see, this is just the time. Today is the last day before your science exam, and you are going to rock it. If you're going to go calmly, don't stress, don't get anxious, don't let the fear reach your head. You know things, okay? The practice is showing you know the answers. So just go with the flow and everything is going to settle down. Let's go with the assertion reasoning, the most difficult questions that we people find that yahi tang karte hain, ma'am, hai na? So let's go with this first question. The assertion says here, a ray of light incident obliquely on a face of a rectangular glass slab placed in air emerges from the opposite face parallel to the incident ray. Is it a true statement or a false statement? First of all thing is to look for that. Then the reason come here, and the reason says lateral displacement depends on the angle of incidence, thickness of the slab, and the refractive index of the material. Now I know you guys do not know much about the reason here, but use your common sense. What you will do, you know that if refraction is happening, on which all parameters will it depend? So think about it. Look for whether the assertion and reason are true individually. If they both are true, only then the option could be A or B, otherwise it will be C or D. So choose your option and we are looking into the chat. Anoop sir, how many people are getting the right answer over there?
A lot of them are giving the right answer. But there's a lot of confusion between A and B though. There's a lot of confusion between A and B. And it's
This is
understandable.
always a thing.
I know, right?
Yeah.
Always. And by the way, ma'am, did you get a haircut or something?
Don't ask me, sir. Don't ask me. I did it on my own and I'm just like doing it.
Oh my
So
god.
yeah,
Amazing.
it is just going to grow back. I just assumed that and it's okay.
Awesome.
Okay, बच्चों के paper है. Let's get back. Let's get
Alright,
back
so
to the.
guys, yes, please, ma'am, please tell the answer. You can go ahead and explain.
So yeah, what do you think, people? What is the correct answer? A and B are always the confusing option. Na? We are able to find the true and false, and that's very easy. But we are not able to get whether my reason is going along with the assertion. So read it together, right? A ray of light incident obliquely on a face of a rectangular glass slab placed in air emerges from the opposite face parallel to the incident ray. Because Lateral displacement. Yes, that is true. Lateral displacement is the reason, right? So lateral displacement depends on the angle of incidence. Definitely it will depend. Second thing, the thickness of the glass slab. Yes, if you have a thicker one, you will have more displaced light. If it will be less, it will be less displaced. And obviously refractive index, that is the very cause of refraction, right? So the answer to this is A, and that just little bit. पहले आप true तक पहुंच जाओ, end में you will get it A or B. Go with your instinct. You know the answers. You know everything. Go with it. What say Anoop sir?
Absolutely.
आ जाते हैं
Totally
ना
agree.
answer?
Totally agree.
Somewhere we know the answers. They are
Exactly.
there. It's just that we get too frightened to write कि यार मेरे को सही लग रहा है, गलत हो जाएगा. Don't do that. Believe in yourself.
So yeah, guys,
Okay?
super awesome. Congratulations, all those who got the right answer. Amazing, guys. Again, please, as ma'am rightly mentioned, when you talk about lateral displacement, it depends on a lot of factors. That is angle of incidence, thickness of slab, refractive index. So yes, the reason does support this assertion that is given. So that will be the answer. Super awesome. Next question. Here it is. Okay, assertion is this, guys. The 20th question. All right, so we're done with 20 questions. That's the 20th question. The center of curvature is not a part of a mirror. It lies outside the reflecting surface. Reason is the reflecting surface of a spherical mirror forms a part of the sphere, and this sphere has a center. Options remain the same. Assertion and reason are true. Reason is the correct explanation for assertion. Assertion and reason are true, but reason is not the correct explanation for assertion. Assertion is true, but reason is false, or assertion is false, but reason is true. Let's go. Come on, people. D.
Now, this one, I'll just give you a hint, just a hint. Read the reason and then the assertion. See, when two things follow each other, if the reason is the correct explanation of the assertion, they both should follow, right? So if you're getting confused, read the reason first and then the assertion. If they're making sense, you'll get to the answer. Come on, people.
Mathematics.
Mathematics,
2 plus 1
sir.
is equal to 3.
Yes.
1 plus 2
1 plus 2 is also 3.
Alright, guys, let's go. Ma'am, by the way, in the meantime, please tell us the story behind you cutting your hair. I really want to know.
Okay, I had a haircut and then those were coming over my eyes. So I took a layer and tick, 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 tick. And then this is what we have. Bangs. Can't help it. Can't help it. So I don't know how much Hindi you know, but घर की खेती है, उग जाएंगे.
That I understood. That I understood.
Yeah, that you understood. Very good. So he understands Hindi. He just doesn't want to talk in Hindi.
Exactly.
Ja, Simran, ja.
Exactly. Anyways, guys, the answer for this question, I am seeing a lot of different answers, A, B, C, and all that. But again,
I guess
people,
A and D is the one which I'm getting the most here. So
yeah,
people
some of
are
you guys are going with option
confused.
B, C also for some reason. People just think about it for 1 second. If you think about the parts of a prism, no, sorry, of a I know what is it, of a spherical mirror.
Sphere.
Yes, a sphere, sorry. Yes. So you have a sphere, right? And remember, if you think of the parts of a sphere, the center of the sphere is what is called a center of curvature. So very clearly, it does not lie on the mirror. Very clearly, it lies outside the mirror. For a concave mirror, it lies in front of the mirror. For a convex mirror, it lies outside the mirror. That is what we call a center of curvature. So clearly, that is true. Assertion is clearly true. Reason is the reflecting surface of a spherical mirror forms as a part. Absolutely. The center of curvature is nothing but the center of the sphere. So assertion is also true. Reason is also true. Reason is the correct explanation for assertion. So that would be the answer for this question, guys. So for all those who are confused about this one, please remember that you need to, think about all the different parts of a spherical mirror, all the different parts, the pole, the principal axis, the center of curvature, the radius of curvature. If you know that, the basic part of it, the different, the different parts of the spherical mirror, you'll be able to easily get the answer. What say, Bhavna ma'am? What do you think?
Just to add on this, I have an example here. So let's take, this is my sphere, right? And my mirror is like this, right? So if I just take a part of it, if I paint the outward, this becomes a concave mirror. If I paint the inward, this becomes a convex mirror, right? Now let's look at this to be a spherical surface. If I consider it as a cross section of a spherical surface, then this center is not lying on the mirror, right? But it does have a center. That's why I said read the reason first, that yes, the reflecting surface is a part of a sphere which will have a center, obviously, right? Then this center is lying outside the mirror. Doesn't matter it's a concave or a convex mirror, right? Now there is one confusion, Anoop, so that I would like you and me to discuss here. Children are very confused. I've seen people getting confused. What is the difference between pole and center of curvature? So when we talk about the center of curvature, it is the center of the sphere as it is written right there in front of you as an assertion. Pole is the center of the mirror. So let's say I take this mirror out Now the center, this also have an individual identity. अभी इस pair से अलग हो गया है. So this individual mirror has a center as well. That is what is pole. So you need to, this is one of the most common questions.
I know, right?
Like
Exactly.
which thing lies there, which thing doesn't lie there.
True.
Now we have been through this too many times. You guys
Exactly.
are doing this for the very first, so it seems, oh my god, ऐसा question भी आ सकता है.
True,
So don't
true,
worry
true.
about
Exactly,
it, right?
exactly, exactly.
Okay, so let's go to the next one.
Exactly.
People, ready?
All right, 21st question. Ma'am, you can read it out if you want.
Yeah, sure. So the 21st question in front of you people, the assertion says the scattering of longer wavelengths of light increases as the size of the particle increases. Now this in one statement is actually asking you everything. If you know the concept of scattering or not. Do you understand what is scattering and how it occurs? If you know so, you know assertion is true or false. Second is the reason. Larger particles scatter light of all wavelengths equally well. Now think about it all together about assertion. First of all, scattering क्या होता है? How does it happen? If that is true, then only the reason. See, there is one very cool thing. If my assertion is false, now I don't even have to read the reason, right, sir? That is what I use as a trick. Why will we waste time in reading the reason?
But that is the biggest problem. That is the biggest problem.
Yeah, that is one of the things, but you should read with to just cross check. It's okay. It's okay. Just read for cross check. Don't do that. But that is really, really great. In your future, when you go for competitive exams, na, assertion reasoning will have a fifth pointer also. That will have, if both are false, what to do with that. If assertion is false, if the reason is true, how to go about this. So 5 आएंगे बेटा, सब आएगा. जिंदगी में बहुत कुछ आने वाला है आपकी. अभी के लिए just have this fun part. If you have to just go with the assertion is true or false, check for reason is it true or false, and then check whether they go together or not. So let's just check this out. थोड़ा सा time दे देते हैं बच्चा पार्टी को. Let's see how many of you are getting it correct. Oh my god, it's A. मतलब everything. If we give option till Z ना sir, it is Z will also come. किसी को बुरा ना लग जाए ना. A को चूज करा तो B को बुरा लग जाएगा. B को चूज करा तो C को बुरा लग जाएगा.
Justice for all the options. India is a democratic country. Every option requires equal opportunity.
Super great. सब आंसर दे दो, सारे दे दो, कुछ छोड़ना नहीं.
Okay, but
oh,
yes,
you guys are getting a bit confused.
Yes,
we will reveal the answer in 3, in 2, and in 1. What is scattering? The first statement is very, very true. That is the very concept of scattering, that when the wavelengths of those light which are comparative to the size of the particles, they are absorbed and re-emitted. That is how scattering is happening, right? So the size of the particle matters the most. In our atmosphere, violet, indigo, and blue scatters the most because the size of the particles in the atmosphere, which is also a colloidal solution, is comparable to their wavelength. बेचारे रेड के साथ कुछ नहीं करा जाता है, कोई इंटरैक्ट ही नहीं करता, बात ही नहीं करता कोई इसके साथ. But if you talk about bigger or larger particles, more wavelengths also start getting scattered. So overall, all the wavelengths are feasible to get scattered equally well. But these two are not going together. The first thing is scattering of longer wavelength of light increases as the size of the particle increases. That's true. If the reason would have been scattering depends on the size of particles, that would have been A perfectly. So I understand this was a little confusing because both were talking about scattering. Both were true, and I guess A and B is the most difficult option to choose from. What say Anoop sir?
Absolutely.
सबसे ज़्यादा मुश्किल A and B में ही होती है. क्या करें? So that is, I understand definitely, but just read twice if you think you are not getting to the point. So I've seen every answer coming there, but कोई बात नहीं. Majority
Exactly,
choose C.
But let me tell you one thing, guys. I know that a lot of you guys might be confused about this reason, sir. How is this possible? Just to, we have not mentioned this in the regular session, neither in the Prodigy session, nor in Vedantu platform also. We've not talked about it much. But let me tell you one thing, guys, that if the particle size is large enough, then yes, all colors can get scattered equally. And more importantly, that scattered light will be white in color. It'll be white in color because all the colors are getting scattered. Like, for example, why is the clouds white in color? I know that a lot of you guys have asked this question in the past. Sir, why is the clouds white in color? It is because of this reason, guys, that the size of the water particles are much more bigger than even red light. Red light, the wavelength of red light is around 700 nanometers. So it's greater than that. because it's greater than that, all the colors are getting scattered, and hence we see it as white color. There is a lot of internal reflection, there's a lot of reflection also happening, there's no doubt about that. But more importantly, the major reason is because all the colors are equally getting scattered, so you don't see a particular color, you're seeing all the colors at once, which is what you see it as white color. So this is the reason why clouds are white, and so reason is also true. So for all those who are confused about it, that is why option B is correct. It's not that reason is false, it is also true, but at the same time reason does not support the assertion here. All right. Okay, so I'm moving on to the 22nd question. 3 more questions, guys. That's all. After that, we'll take up your doubts. Also, both of us together will take up your doubts as well. 22nd question, guys. Assertion is danger signals are made of red color. Reason is velocity of red light in air is maximum, so signals are visible even in the dark. Options are both assertion and reason are true. Reason is the correct expression for assertion. Both assertion and reason are true. Reason is not the correct expression for assertion. Assertion is true, but reason is false. Assertion is false, but reason is true. Guys, are you able to hear me loud, clear enough? One sec, let me just check my volume. Just give me 1 second, guys. I'm just going to check my volume a little. Can you guys hear me now? Is it better? Can you guys hear me now? Clear, not clear? What is it? All good? All right. Okay. Yes, ma'am. So what do you think is the right answer, ma'am, here?
Me. I'm Anoop Sir थोड़ा आने वाले एग्जाम में ना you guess. Come on, which one? I guess this is one of a bit of a common sense wala thing also, na? We do see danger signals as red or not. We can just analyze our surroundings and we look for assertion. The major thing is about the reason. Now, reason can be confusing, but let's see whether people can get it true or false. Come on, people, let's
Guys,
go.
I'm sorry. People, can you hear me clearly now? 1 second, ma'am. I'm just checking. Guys, can you hear me clearly now? Is it clear now? Can you guys hear me now? Is it better? No. Yes or no, guys? Can you get a quick answer for that? Because otherwise, there's no point in me shouting. Yes. Oh, Baban's voice is no. No. Okay, 1 second. Either one goes up and the other goes down. 1 sec, 1 sec. Is it better now? Now, can you guys hear both of us clearly? All good? Now it's clear, no? Bam, can you just say a couple of words so that
ऐसे मेरे को speech देने का बोला गया. Please say a couple of words. While getting
the
to
way
the
that you
point.
laughed,
Thank you very
it
much.
reminded me of Joker from that Batman movie all of a sudden. All right, anyways.
Clear, Mr. Badi? Is
Okay,
my
guys.
voice
So, what do you think is
clear?
the right answer? What do you think is the right answer? A lot of you guys are going with option number C. I can see a lot of people going with option number C, some with option number D as well. However, the answer for this question, guys, is actually option number C itself. Let me tell you why. Because people, yes, red color is used for danger signals. Why? Because it has a larger wavelength. Because it has a larger wavelength, it does not scatter as much. It does not get scattered as much. And remember one more key factor, guys, that all colors have the same speed in air. In air, every color, be it violet or red, they all have the same speed. They'll have the same velocity. Only when they enter into a different medium that their speed might vary. But in vacuum and in air, the speed of light for all the colors would remain the same. So that means that red will also be traveling at 2.99 into 10 to the power of 8 meter per second. Violet will also be traveling at 2.99 into 10 to the power of 8 meter per second. So all colors have the same velocity. The key factor is that there is larger wavelength. Red has a larger wavelength, so it does not scatter as much. So that should have been the reason. So assertion is true, but reason is false in this case. All right. So it's not because of that. Is that clear? Understood, people? Everyone clear with it? Yes or no, guys? Come on, quickly. Now we have a lot of questions, and we also want you to get your doubts also cleared. So is that clear, people? Quickly. Option number C. Yes, option C. Oh, option number C. Oh, did I? Option C. I meant option C. All right. 23rd question. Come on, guys. Ma'am, yours.
Come on.
You're lost in the chat box or what?
Yes, I'm lost in
Lost
the
in chat
lab.
box.
Yes. I was just reading. Everybody got it? Yes, everybody got it. That's
Awesome.
amazing. So this could be a very confusing question because that was the speed of light for different colors different in prism. But
Right.
in air it is same. So people go there. Oh, नहीं, ma'am ने तो ये पढ़ाया था, sir ने तो ये पढ़ाया था. That's what happened. Yes, so let's read the 23rd question, people. The question here says, large concave mirrors are used to concentrate sunlight to produce heat in solar cookers. Is it true or false? I guess this is one of the most easiest assertion I have read in some time. Then the reason says concave mirrors show both positive and negative magnification. Now you just first have to check whether they both are true. If they both are true, only then A or B can be there. But if anyone is false, C or D. If they both are true, look, is there any connection between the magnification and where the sunlight is being concentrated at the focus? What is the right answer? Come on, people. Let me just see all the answers very well.
Lots of
काफी सही
these.
answers आ रहे हैं.
Awesome,
I
awesome,
guess this
guys.
is easy.
I know, right?
This
This
is
is
easy.
very straightforward question. This shouldn't be there in board exam, no? What do you think, ma'am? It shouldn't be
No,
there.
sir, it could be. Could be. There
Too
might
easy.
be
This
some
is
easy questions. Some easy.
too
You
easy. This
need
is
to
way
be
too easy.
prepared for everything. Easy है, मुश्किल है, देख लेंगे. Right?
Awesome, guys. Awesome. That's super awesome, guys. Super
Very
awesome. I can see that everyone is giving the right answer over here. Super duper amazing,
Give
guys.
me that thumb. Give me that high five, bacha party in the chat box. Super great.
Amazing
Everybody
job,
got it.
guys.
Super
Definitely
great.
correct. Absolutely, option B is correct. Ma'am, do you want to take it up? Like, explain why?
That's really, really amazing. People, yes, this is the question from the application of the mirrors, spherical mirror. So you need to first know which mirror is used where. And the second thing that is very important for you to know why. So when I say that a solar cooker is used for cooking, right? Using the sun power. So what happens when the light falls on the concave mirror, it gets focused, or let's say concentrated at the focus. So if I put a cooker or anything, a pan like structure there, my food will get cooked, and that's an amazing, amazing way. So concave mirror is used in such a way. Perfect. It is true. Second thing, concave mirrors show both positive and negative magnification. That means it can form both erect as well as inverted images, which is also true. Concave mirror is capable of making real images, and in one special case where the object is between focus and the pole, we get a virtual image. But is there any relation between these two? There is none. All the light from the sun can be focused. That is the converging nature of the concave mirror. But the formation of erect and inverted images has nothing to do here. क्या फर्क पड़ रहा है? Light sun सीधा बनेगा या उल्टा बनेगा? It should be concentrated at the focus, right? That's
Exactly.
it. So the right answer goes to B. It doesn't go to A. Both are true, but the reason is not the correct explanation of the assertion. Got it, people? Super
Awesome,
great.
guys.
Give me
Awesome
a thumbs
job.
up quick.
All right, so people, finally we are done with assertion reasoning type question. Now again, please remember that those are not all the assertion type or reasoning type of questions that you can expect in your board exam. There are different types of questions, and assertion reasoning type question basically checks your knowledge. It checks your understanding of the concept. That is why you need to know your concepts very clearly. So please pay attention wherever you're making those mistakes, those silly mistakes. Go back to your NCRT, take 1 hour of your time, read through the topic one more time. Let's say that you're finding dispersion and scattering a little difficult. Go through the topic once so that you're clear with it, so that you don't repeat the same mistakes in your board exams later. All right, that is what I'm going to say. Oh, it's lagging. All right, guys.
In between, it is lagging. In between, it is lagging.
Amazing. Super
But there is
awesome.
some good news also. I just saw two messages, Yaduraj and Rashmita, saying that it is 1K like already.
Oh,
Where
is it?
are all
All right.
the people liking? Come on, people, super great.
People, thanks a lot for
Very
that.
great.
If you haven't liked it yet, what are you waiting for? Hit the like button. All right. Case study based question, guys. The 24th question. Here it is. Suppose a car is traveling across the road towards a muddy track at an angle. The mud shows down one side or slows down. It's not shows down, it slows down one side of the car, and the path of the car bends. The more it is slowed, the more is the bending of that car. Upon exiting the track on the opposite side, the car speeds up and achieves its original speed. This analogy represents a light wave traveling from rarer medium to denser medium. Thus, a ray of light traveling from a rarer medium to denser medium bends towards the normal, and when it travels closer from a rarer medium to denser medium, it bends away from the normal. Sorry, denser to
This
rarer
will be
medium.
denser, not closer, denser medium. From denser medium to rarer.
Oh my god, so many mistakes. So it slows down at denser to rarer video, guys. Couple of typing errors, please ignore that. Okay, it's a very simple analogy, guys. This is what they're talking about basically. So it's nothing but the same thing what happens to light. They've showed it in terms of a regular day-to-day example of car entering into from a tar road to a muddy road, something like that, right? So here's the question. Ma'am, okay, you can read it if you want to. Yes.
Okay, so this is actually the topic of refractive index, which is everyone's favorite topic, I guess. Everyone's. I don't understand, even after giving our exam, we will be confident about this topic.
Okay, ma'am, I'm not able to. Amazing. I think my internet is down. I'm not able to hear, ma'am. Just give me a second, guys. Can you hear, ma'am? Are you guys able to
Talk
hear?
about refraction. Yes.
I was stuck for a couple of seconds. Oh, please continue. I'm so sorry. My internet got stuck. I was like, what happened to
Yeah,
me?
I can read your internet connection is unstable. Is it mine or is it
Yes.
you?
No, I think it's me right now. Yeah. Please go ahead.
Okay,
Sorry.
no worries, it's okay. So yeah, refractive index when we talk about, so the in the whole, can you just go back to the passage once, sir?
Sorry,
So
ma'am. Please.
whenever you read the case students passage may always look for the thing, the key concept that the passage around. All your four questions will be around that passage. Okay? So make sure you know the key concept so that you कहीं का पूछा और कहीं का आंसर नहीं दे रहे हो आप. Right? So it is about glass slab, it is about refraction. Wherever refraction goes, refractive index follows. So the very first question out here, the speed of light in air is given to be 3 lakh kilometers per second, and that in the glass slab is given to be 1,97,000 kilometers per second. That's huge, right? What is the reason for the difference in the speed of the two media? Is it the difference in the density? Is it the difference of the amount of light which is going from air to glass? Is it the difference in density of wind flow? So as the wind is flowing, the light is flowing because of that, or is it difference in the temperature? What is it that is making the speed reduced? Now this question, I'll just do one more thing, but you have to always go with the most probable answer. So what is the most probable answer of this question? Come on, people. What do you think?
Everyone is
Anoop
going with
sir,
the
please
right
sir.
answer,
Arey
ma'am.
baap re baap.
Everyone.
Everybody knows this. Case-based
I,
question, we are heroes. We
I,
are smart enough, right?
super
Super
awesome,
great,
guys.
people. Super great. Very
Absolutely,
well done.
absolutely, absolutely. No doubt about it, guys. The more the density, the slower would be the speed of light. So it's very clear that when light is entering from one medium to another, there is the density is what is causing that change in speed. Although, to be honest with you guys, the temperature can also matter, but we have not studied about it right now. You'll study about that in your higher grades. Temperature does matter because temperature can decrease. Higher the temperature, lesser would be the density, which you study in mirage. In mirage formation, you would have probably studied about that. So temperature also matters, but the major reason is density. That is why option A is more accurate here. All right.
The point, that is what is important. When you read that question, do not get missed in two options. Go with the most probable one, and the
Exactly.
answer would be better if it would be optical density.
Right.
Do take into consideration mass density and optical density are not equal. Right,
Exactly.
people?
Exactly.
Great.
Right, guys.
Super.
Okay, very quickly, guys, because we have another 5 minutes before the chemistry session starts. So if Shilpi ma'am waiting on the other side, so if we extend the session any further, Shilpi ma'am is gonna later. So here's the question: which of the following explains the laws of refraction of light through the glass slab? Options are: light always bends towards the normal in a glass slab. The incident ray, the refracted ray, and the normal of the or to the interface always lie on the same plane. Ray of light traveling in the air is always considered as the incident ray, and the one in the glass is called as a refracted ray. The ray of light always travels in a straight path, irrespective of change in medium. Which of the following follows the laws of refraction, guys? Remember the two laws of refraction. With respect to your laws of refraction, which of these options is something which complies or which goes along with the laws of refraction is the question. All right. Amazing people. Arre, super awesome. Everyone. Okay. Neil ji, please check your answer now. Please check your answer. Neil, check your answer. But
There's
everyone
just
else is
one
good.
confusion the kids are getting into. All the statement looks true, and they are also.
True,
But you
true.
have to go for the law, not like
Exactly,
which
guys.
statement
The
is true
two
according to
laws
the
of
glass slab.
refraction. Please focus on that.
Super
All
great.
right. So, with respect to the laws of refraction, guys, option B is more accurate because if you remember the laws of refraction, the first law of refraction states that the angle of the refracted ray, the incident ray, and the normal will all lie on the same plane. Second law is nothing but your Snell's law. The ratio of sine of angle of incidence to the sine of angle of refraction is basically a constant for a pair of medium. So, option B is more accurate with respect to laws of refraction. So, that is the right answer for this particular question. Again, it's not something that you see very regularly, right, ma'am? I mean, ma'am is very busy drawing some super awesome drawings. I don't even know what that is, but yes, I think it's a tongue popping out. Amazing. Thank you, ma'am.
Okay, sir. Okay.
I thought I was the worst, worst artist in the world, but yeah, you turned out to be better than me.
I have figured out.
Let's go.
Next.
Let's go. Okay, so
Yes,
24th question, guys. 24th question, part 3. Very quickly, guys. A ray of light continues moving along the same path while passing through air glass interface. The angle of incidence for the ray is going to be 0 degrees, 90 degrees, less than 90, or greater than 90. If a ray of light is passing through air and glass, two different medium, and still, if it is passing through without any deviation, then what does that mean? What should be the angle of incidence for that thing to happen? Should it be 0? Should it be 90, less than 90, or greater than 90? Come on, guys. What do you think,
Many
ma'am?
people are getting confused. Many people. Still, it is a very easy question, but still, there's something is
I know,
getting
right?
something.
All right. So quickly, guys, I'll give you the answer in another 5 more seconds. Very quickly, put on your answers in 4, 3, 2, 1. Absolutely, guys. Absolutely. The answer is going to be 0 degrees. If the angle of incidence is 0 degrees, please remember the ray of light is going to pass through undeviated, without any deviation. It's going to pass through it. So angle of refraction will also be 0 degrees itself. Because again, guys, we are talking about the normal. So the ray of light is basically incidenting exactly on the normal, which means that angle of incidence is 0, because angle of incidence is the angle formed between the incident ray and the normal, not with the mirror or not with the refracting surface. It's always between the normal, right? So for that reason, guys, option A is the correct answer. Don't ever forget this. This is the reason when you talk about the standard incident ray, a ray of light passing through the optical center passes through undeviated. No, it is basically with regards to the same phenomena that you've seen over here right now. Okay. All right. So 25th question, ma'am. Please
Okay,
go
let's
ahead.
read it quickly. When a beam of light strikes such fine particles, the path of the beam becomes visible. The light reaches us after being reflected diffusely by these particles. The phenomena of scattering of light by the colloidal particle is known as Tyndall effect, after John Tyndall, just the asterisk mark. Tyndall effect can be observed when sunlight passes through a canopy dense forest. Okay, so Anoop sir is now back to his drawing. If you are reading, I'll do the drawing. But yeah,
Exactly.
this case again. Now this is from the chapter of colorful word. I hope you got the concept already. We are all talking about Tyndall effect, so it is all about scattering here. So all the following questions will come for scattering. So let's start with the very first question. Everybody ready? Read the case. Let's start. First question, if the size of the scattering particle is large, then what is going to happen? We have done an assertion reasoning. I hope you guys going to get the right answer of this one. The scattered light may appear violet if I have larger particle. The scattered light may appear blue. Will it appear white, or will the scattered light appear yellow? What will be the right answer? Anoop sir practically answered this question
Exactly.
previously.
Exactly.
Let's see whether you can get this or not. 5
I want
seconds.
to know
Come
how
on,
many
Anoop
people,
sir.
how many of them are paying attention. I want to know how many of them are paying attention. This question will tell me how many of them are actually paying attention and how many of them are just chilling out in front of YouTube right now. This will
सब
tell.
इधर उधर जा रहे हैं ABCD we know how to study ABCD EFGHI we know that go with one particular answer people super good now some clarity is coming
Awesome, Riddhi.
if the
Nice, Ashika. Karen ji, awesome.
particle
Pramod. Amazing,
come
amazing.
on people where is the Josh jaldi se dikhao
Guys,
okay
one sec. I'll just check ma'am's volume. Can you hear ma'am now? Can you guys hear both of us clearly now? Is it better? Is it better now? Please answer this now.
sir I can hear myself clearly in my phone so it's
Okay.
fine I guess
All right. All good. No. All right then. Okay, guys, quickly, go. All
the
right.
right answer is yes. The path is very great, ma'am. ABCD. Very
Everybody,
good.
all
I
right,
know
anybody can dance.
anybody can dance. True.
All right, so
Very
guys, very quickly, the answer for this question
Come on.
in 3, 2, 1 is going to be white, people. It's going to be white. I told you, if the particle size is big enough, it will scatter all the colors equally, which means that the color would appear white in color. The reason why the clouds are white is because of this, because all the colors are big. So you need to understand this, guys. Generally what we say is that colloidal solution is between like 1 to 1000 nanometers, right? This is what we say, that light can easily get scattered if it's between 1 to 1000 nanometers. But if you want all the colors to get refracted equally, then the particle size has to be much more bigger than that. Like somewhere it has to be bigger than red light, so it can be around like generally it should be around maybe around 20 micrometer or around 20,000 nanometers, something around that. So at that point of time, if the particle size is big enough, again 20,000 nanometer, if it is big enough, then yes, all the colors can basically get scattered equally, and thus it'll appear white in color. All right. Yes, too much information, no? Too much information.
Too much information.
25th
Sir, बह गए भावनाओं में.
Exactly. Lost in thoughts. All right. Here's the question. Yes, 25th question, second sub question. Let's go. The color of scattering light depends upon what? The nature of the particle, the size of the particle, the volume of the particle, or the density of particle. What does the color of scattered light depend on? Let's go. Let's go. Let's go.
Super easy, people. You know the answer. And yes, do not forget after this, Shilpi ma'am is coming right away. So कहीं नहीं भागना है. खाने की प्लेट लेकर बैठ जाना. Eat your lunch there and do not miss Shilpi ma'am's session. Okay, people? She's going to be live with all your chemistry doubts and your whole marathon is going on. Do not miss it. Not for anything in the world. Okay? Come on. What is the right answer? Quickly.
All right, guys. In the answer in 5 seconds. 4, 3, 2, 1. Pretty much all of you guys are giving the right answer. It is the size of the particles. The bigger the size, exactly. I've already explained this. The bigger the size, the more the scattering of light. So yes, option number B has to be the right answer.
Who is taking the credit? I have already explained this. You guys got it correct because I have explained this already.
Obviously, I'll take it.
So obvious, so silly of me, है ना? Carry on.
I'm kind-hearted like that, ma'am. I just give away credit. So sometimes I want it back. Sometimes I want it back. All right. Okay, 25th question, guys. The third sub-question. The phenomena of scattering of light by colloidal particle is known as... Ma'am was already told the answer. You take the credit. I was already told the answer.
Yeah, I have told you the name of the scientist as well, right? Like
Tyndall effect, corona effect, COVID-19 effect, dispersion effect.
Right, I read that.
Or Tyndall and dispersion.
Corona effect, it is your exam wala time, not the scattering wala time.
Exactly. Guys, that's a different phenomena. Don't think that it's corona, the COVID-19 thing. It is not the virus. Not the virus. Alright, okay, let's go. Quickly. Come on, guys, quickly.
Super. Great. Come on, quickly, because Shilpi ma'am is waiting for you guys. 1.2k likes are already there.
Exactly, guys. Hit the like button. If you've just joined us right now, hit the like button. If you're enjoying the session, and more importantly, if you're getting
attendance like that, okay?
Exactly. And if you're getting out, good value of whatever time you're spending over here, please hit the like button. Show some appreciation, right? Yes. All right.
Do subscribe to the channel. There are a lot more marathons coming up. There are a lot more paper discussions coming up. If you are into the channel, you will not miss a single thing. So do subscribe to it, right?
So,
make your friends also. Aajo, सब लोग साथ में part लेंगे marathon में, right?
All right. So the answer for this question, please, ma'am, because you already told it. Please, you announce it.
So याद कर लो टिंडा, ठीक है? I don't think so anybody out there will love टिंडा. टिंडा is a sabji. I don't know Anoop Sir knows this or not.
I say it is Tinder effect.
Anoop Sir has
It's
different
worst.
logic. In fact,
I didn't cover with it. I didn't cover with it. It was actually one of my students who came up with this one. So she started calling it Tinder effect.
And you took it.
Took
it. Okay, Tinder effect.
It caught on. So I'm like, okay, Tinder effect.
Last question, I guess. The last question we have here now. Whoa, people, the last question of the whole marathon. You guys are going to rock it. Let's just do it and prove it that everybody is going to get it correct. The question is, the blue color of the sky is due to, oh my goodness, so easy. Red color is absorbed. Red light is preferentially scattered. Blue is natural color of the sky. Or blue light is preferentially scattered. We are talking about our atmosphere. Who do atmosphere preferentially scatter? Which one is that? Is it red? Is it blue? Is it red light ne bola apun absorb hoga? Or blue light said ki no, I am the natural color. Come on, people. Quickly, I guess everybody is going to get to the right answer of this one. I don't think so anybody would get wrong. Super great, people. Super great. सर इतना easy question नहीं डालते. CBSE भी नहीं डालने वाला है. But नहीं, हमारे बच्चे बहुत smart हैं. That is the point. You guys are amazing. I was somewhere doing some house.
It's okay, ma'am. It's okay. Is it, guys? Can you guys hear us, see us very quickly?
No, it's lagging.
Okay.
It's tough.
One sec. One sec, guys.
Do you want me to host it?
Yeah. Please, ma'am. One sec. I'll just.
If you make me host, the network will be fine.
Hold on, I'll just make you the host.
Nahin, you are nahin hoga. You are actually doing it from OBS, na?
Yes. Guys, can you hear us, see us? Again, my power is gone. Today is a wonderful day,
sir,
so I'm sorry for that.
Anyways, bang
anyways, quickly, guys, the answer for this question. I'll just change this. Hold on for 1 second. All right, I'll just share my screen with you guys. Yes. So, anyways, quickly, guys, the answer for this question, by the way, is going to be option number D, without a doubt. It is going to be option number D. That it's the scattering of light for blue is the high. Or you can't say it's highest, but yeah, it gets scattered a lot. More importantly, it is reaching your eyes. Since it is reaching your eyes, the sky appears blue in color. That's all. That is the answer for that. All right.
So the particle size in the atmosphere is comparable to the wavelength of the
Yes.
blue or
Yeah.
the lower wave. Right?
Yes. You can
That's
say
it.
that.
That's it.
Yes. That's it.
Super great.
All right, so guys, preferentially means what to say. You can say that it is given a lot more important. What to say.
Importance, right?
Importance,
True.
like
मेरे
more
को
importance.
जो मुझे मिलती है.
Oh
I
yes,
am
yes.
preferred.
All right, so anyways,
That's
guys, that was the last question, and please remember this every time you're feeling scared that we are always with you guys every step of the way. We'll always be with you no matter what, and stay confident that the entire team of Vedantu is with you guys. You're not alone. We've all been through it, so we understand what you're going through. But yes, be confident that we are always with you guys, and with that confidence, get into your exam hall tomorrow and for them. Right, break everything, break the table if you have to, with that josh. All right, and set yourself not actual fire, but yes, stay very much energetic and do well. That is all I can say. All right,
super great.
anything that you want to add, Ma?
No, sir, you have done you said more. It's like all the place, just go and rock it, छोड़ कर आना,
Exactly.
just go for it. And yes, biology is already done by Maria ma'am. Students are asking right now. Chemistry session live is going on with Shilpi ma'am. Go to that session right away, okay? So all the best, people.
All the
Rock
best.
it.
Exactly. All right, and remember, break your table. Don't forget, after the last day of your exam, don't break that table. With
Break
that
your leg.
josh.
That's for good luck.
Exactly. All right. So good luck,
Bye.
guys. Once again, all the very best. Do really, really well. And again, I'm saying this that all of us are with you guys. We've all been through this. I'm telling you it again and again. We've all been through it. I'm sure that your anxiety is low now. It is a lot. I'm pretty sure that by the end of this 1.5 hour, at least 10% of your confidence would have gone up. So I'm hoping that that is the case. Then it was a well spent 1 hour or 1.5 hour, whatever it was that you spent with us, right? Good luck. Do not forget to subscribe to the channel because we have so much more content coming your way. And apart from that, we also have the term 2 preparation. It'll be much more dhamakedar than this. My Hindi, yes. It is going to be much more bigger, much more, much more of a bigger celebration than this. So make sure you subscribe to the channel, hit the like button, and keep following us, keep supporting us, right? Good luck. All the best. Good luck. All right, guys. See you soon. Bye-bye. Yes. Take care, guys. Bye-bye. See you all.
Take care. Bye. All the best.